1 divided by x. In order to get a good idea of what this looks like, we can go ahead and pick some points for this one. So let's go ahead and do so. So if we start at 0, notice what happens. If we plug 0 in, what do we get? Well, we get a 0 in the bottom, so this is going to be undefined. So we're going to start with undefined at 0, and let's move outwards. So just for this example, to get a better picture, I'm going to start with positive 1/2 and negative 1/2. And additionally, I'll do negative 1 and a positive 1. So if we plug in a negative 1/2, well, that would be a 1 divided by a negative 1/2, and that's going to get us a negative 2 here. The negative 1, that's going to be a 1 divided by negative 1, or a negative 1. The 1/2, that would be a 1 divided by 1/2. So what is that going to get us? Well, that's going to get us a 1 divided by 1/2, or in other words, a positive 2. And then the positive 1 will get us a 1 divided by 1, or a positive 1. So if we come over to our graph and see what this looks like, well, we'll say that this will be 1/2 right here, and then this one will be 1. And additionally, we'll say this will be 1/2 right here, and this will be negative 1. And then we'll come down 2, and we will go up 2. So let's plot our points. We know at 0, 0, we're undefined, so let's go ahead and move in either direction. 1/2, positive 2 is going to have a point right there. And 1, 1 is going to be right there. Negative 1/2, negative 2. Negative 1/2, negative 2. And finally, we have, in this case, negative 1, negative 1. So negative 1 and a negative 1. Right, so if we connect our dots here, we should end up with a function that looks something like this. And this is going to be our rational function here. So let's go ahead and figure out what the domain and the range is. So the domain in this case, if we go left to right, is going to be, well, let's look and see, left to right. We're going to go left and then continue to go right, and we're going to get really, really close to this 0, but not quite touch it. So in this case, we will go from negative infinity to 0. And if we continue to go left to right, we're going to start kind of at 0. Again, we're not really going to touch it, but we're going to start really close to it, and then continue to go out to positive infinity. So we need to go ahead and include another interval using the union, and this will be 0 all the way to infinity. Okay, let's go ahead and do our range now. So our range, if we go from, in this case, negative infinity to positive infinity, let's see what happens. So now we're going to go ahead and start from the bottom. So we're starting from negative infinity, and then we get really close and we almost touch 0, but not quite. So what can we conclude? Well, our first interval is going to be negative infinity to 0. And our second one, if we start really close to 0 and then continue to go upward, in this case we will have 0 to infinity. Alright, let's figure out our intervals of increasing and decreasing if we have any. Well, as we move left to right, so left to right, let's go ahead and highlight that real quick. So left to right, it looks like we are only decreasing, right? So as we move left to right, we are only decreasing. So in this case, we will be decreasing from negative infinity to 0, as well as decreasing from 0 to positive infinity, right? Because notice how left to right, again, we move in this downward direction, and again, moving left to right, we move in that downward direction. So we don't actually have any interval of increasing, so we don't need to put anything there. Okay, let's look at another example. say we wanted to look at the graph of y is equal to 4 divided by x. Let's go ahead and figure out what this one will look like. So again, let's go ahead and start at 0. If we plug in a 0, notice what happens. Our bottom is going to be 0, therefore we will be undefined. And additionally, let's pick some points. In this case, a -1 and a -2, and a +1 and a +2. So that will leave us with a -4 here, and a -2, and a +4, as well as a +2. So let's go ahead and see what this one looks like. We're going to go ahead and go 2 out on the left and the right hand side, and we're going to go up 4 and down 4. So again, at 0 we are undefined, so let's go ahead and take care of our 1, 4 and -1, -4. So 1 and then 4, and then we have a -1 and then a -4. Additionally, we have a +2, +2, and then -2, -2. Okay, so connecting our dots, what do we get? Well, we get something that looks kind of like this. So this is what our rational function is going to look like. And we can go ahead and determine what our range, our domain, increasing or decreasing if we have those intervals as well. So our domain, let's go ahead and see what that one's going to be. Moving left to right, what x values do we hit? Well, we essentially hit -infinity to 0, and we want to go ahead and use a parenthesis but not a square brace, because at 0 we are actually undefined. So last we have 0 all the way to infinity as our second interval. Now let's deal with the range. So our y values, what can we take on? Well, we can pretty much take any value except for y. So let's go ahead and go -infinity all the way to 0, and then 0 all the way to infinity here. Interval increasing, moving left to right. Do we ever increase in this case? Well, we don't. We only decrease. So moving left to right, notice we decrease, going from -infinity, and then we get really close to 0, but we don't quite touch it. And again, in this case, we kind of start at 0, but again, we're not touching it, and then we continue out to +infinity. So how can we write that? Well, our interval of decreasing is going to be -infinity, 0, union 0 all the way to +infinity. So that should about wrap it up for our y is equal to 4 divided by x, and we can go ahead and look at some more complex graphs here. So in this example, what we're dealing with is f of x is equal to 2 divided by x plus 1. Now, the way that we can rewrite this one is this way. So we can rewrite it like this and just move the 2 out in front. Now, it looks a little bit familiar of the graphs that we've been dealing with the 2. And then in the parentheses, now we have an x plus a 1. So we can conclude some information from this. We can say this 2 tells us that we will be vertical stretching by a factor of 2. So vertical stretch. And then in this case, factor of 2. And then our second piece of information tells us that this x plus 1, we are going to go ahead and move to the left 1 unit. Okay, so let's go ahead and pick some points to figure out what this graph is going to look like. So let's go ahead and start with a -1. As this -1, notice what happens when we plug in -1 into our function. We get a 0 in the bottom. So we're going to start with undefined. And additionally, let's move out in the negative and positive direction. So if I plug in -2 and then -3, I should get some values, as well as a 0, a positive 1. So let's go ahead and try those values, see what we get. So in -2, if I plug in a -2, I'll get in the bottom a -2 plus a 1, which will be a -1. So we should get a value of a -2. If I plug in -3, I should get a -1. And then a 0 should produce a 2. And then finally a 1 should produce a 1. Alright, let's figure out what this graph looks like given the information that we just created. So we have a point at -2, -2. So -2 and then -2. Point right there. And we have a point at -3, -1. We also have points at 0, +2. And we have a point at 1, 1. So connecting our lines or dots, we should get a graph that looks something similar to this. And let's go ahead and connect these other two dots here, or points. And we should get a graph that looks something like this. So important pieces of information: our domain, our range, interval of decreasing, because we will not have an interval of increasing, and then finally something that we will just introduce. We will introduce our horizontal asymptote. And additionally, we will have our vertical asymptote. So I'm just going to go ahead and abbreviate it. And let's figure out what this information tells us. So for our domain in this case, we'll start at -infinity. And we will go all the way to, and it looks like we'll stop at -1. So we can go ahead and summarize that by saying -infinity to -1. And what else do we have? Well, if we go from left to right and we continue on, we almost start at -1, but we don't quite touch it, and then we continue to go on to +infinity. So again, that's why we use the parentheses, not the square brace. So -1 all the way to +infinity. That's going to go ahead and be our domain in this case. Let's figure out what our range is. So if we start from -infinity and we continue to go upward, well, what do we stop by? In this case, we are stopped by 0. So we can go ahead and conclude range starts from -infinity to 0. And then if we continue on, we'll start approximately at 0. Again, we're not quite touching it, and then we continue to go all the way up until +infinity. So we will be at 0 and then all the way to +infinity in this case for our range. Okay, so interval of decreasing, it's going to be very similar to our domain here. So interval of decreasing, again, this is going to be -infinity to -1. And then -1 all the way to +infinity, again, because we are moving from left to right. Okay, our horizontal asymptote and our vertical asymptote. Our horizontal asymptote, notice how our graph never touches this line right here, or in this case, y is equal to 0. So that's going to be our horizontal asymptote. Now, our vertical asymptote, notice how our graph never touches this invisible line. In this case, it's -1. So our horizontal asymptote, we can say x is equal to -1. And we will go a little bit more in depth on how to find these asymptotes. So let's go ahead and proceed to our next example, and later on we will look at that specific information. Alright, let's go ahead and figure out what our rational function f of x is equal to 1 divided by x squared looks like. So let's pick a point of 0 first. 0 will get us a 0 in the bottom or an undefined. Additionally, we want to go ahead and plug in plus or minus values. So plus or minus 1/4. And the reason we want to do a plus or minus is because we can go ahead and take care of positive and negative values with this squared. So that squared will produce a positive value if we plug in a positive, or a positive value if we plug in negatives. So a positive or negative 1/4 gives us a positive 16. a plus or minus 1/2 should give us a 4. And then finally, a plus or minus 1 and a plus or minus 2 should give us a 1 and a 1/4. So let's go ahead and graph this and figure out what it looks like. Again, at 0, we're undefined, but we do have values at 1/4 and 16 and negative 1/4, 16. So let's go ahead and do little tick marks. So 1, 2, 3, 4. Those will represent quarters of the 1 value. And then finally, we'll have values there. And we can go vertically for our graph up to 4. Again, we don't really have the space for the 16, so let's go ahead and look at the plus or minus 1/2 and the 4. So plus or minus 1/2, and then we'll have a value at 4. And then we'll have negative 1/2 and a positive 4. And we'll have, in this case, plus or minus 1. So plus or minus 1 and then 1. And we will also have a negative 1, 1. Okay, and our last value we have this 2, so plus or minus 2 and then 1/4. So it's going to be really tiny, approximately right there. So let's go ahead and fill in our graph here and figure out what it looks like. We should get something that looks approximately like this. Okay, so domain and our range, let's go ahead and figure out what those are. Our domain in this case, let's go ahead, see. Domain, our x values that we hit, negative infinity to 0. So negative infinity to 0. And additionally, we go from 0 all the way to positive infinity. Okay, our range, we're not really taking on any negative y values. So in this case, we will just have 0 all the way to positive infinity. Our interval of increasing, in this case, we will be negative infinity to 0. Because if we move left to right, negative infinity all the way to 0. We're moving kind of in an increasing direction. And second, for our decreasing, if we move left to right, we will essentially be from 0 all the way to positive infinity, because again, we are moving downward. So let's summarize that. Increasing, we said, was negative infinity to 0. And decreasing was 0 to infinity. So let's look at our g of x, which is equal to 2 divided by x minus 2 squared, and then finally minus 4. So again, this one's going to be a little bit more complicated as we're adding some translations to the graph that we previously looked at. So in other words, we can pull out some key pieces of information. We could go ahead and pull that 2 out in front. We can go ahead and look at this x minus 2, and then finally the minus 4 and figure out what it tells us. So this positive 2 is going to tell us that we are vertical stretching by a factor of 2. So stretching in this case, and then a factor of 2. So factor of 2, and this x plus 2 tells us that we need to go ahead and move to the right 2. So right 2. And the last piece of information, this negative 4, is going to tell us that we go down 4. So down 4, let's go ahead and pick some points to figure out what this one is going to look like. So I'm going to start with a 2, as this will give us a 0 on the bottom, or an undefined value. So we can go ahead and say undefined for this one. So undefined for 2. And additionally, we'll have a 1 and a 0. And we will have a 3 and a 4. The 0 will give us a negative 3.5. The 1 will give us a negative 2. The 3 will give us a negative 2. And the 4 will give us a negative 3.5. So if we proceed to plot this, let's go ahead and see what it will look like. We'll have a 1 and then a -2. So 1 and then -2. We'll have a point right here. And we have a point at +3, -2. So +3, -2. And additional points of 4 and then -3.5. So 4 and then -3.5, approximately right there. And last we have 0 and then -3.5. So that point will be approximately right there. Now, if we proceed to go ahead and graph this, this is what our approximate function will look like. Okay, and then our left side should look approximately like this. All right, and notice how we have some invisible lines going on. So we have this invisible line right here. And our last one we have is actually at 4. Right there. So we can go ahead and summarize that information after we find our domain, our range, our interval of increasing, our interval of decreasing, and then last we will have a vertical asymptote and a horizontal asymptote. So interval for our domain, we're going to go ahead and go from -infinity all the way to, and it looks like we're stopped here at this +2. So we can go ahead, do our right hand side as well. We'll start at that +2 and then go all the way to infinity. So in other words, we can say -infinity to +2 union 2 all the way to +infinity. And then for our range, we basically start at our -4 here. So -4, and then we continue to go up to infinity, and again, start at that -4 and go on to infinity. So we can summarize that by saying our range is -4 all the way to +infinity. Interval of increasing, that's going to be this -infinity to 2. Notice how moving left to right, we move in an upward direction. And then from 2 all the way to +infinity, notice how we move in this downward direction. So that will be our interval of decreasing. So interval of increasing, -infinity to +2. And decreasing, +2 all the way to +infinity. Okay, so now comes the part where we talk about those invisible lines that we don't quite touch. So our vertical asymptote, what line is that? Well, it is the line of x is equal to 2. And that line again is located right here. And we don't quite touch it, so that's our vertical asymptote. And then our horizontal asymptote, the line that we just don't quite touch, is going to be this y is equal to -4. So y equal to -4.